So this is June 2020 paper, 6 variant 1. The first one is question number 2. So the first doubt is question number 2, part A. So this question is about organic compound P, Q, and R. So there's an organic compound P, Q, and R. The compound are isomers C4H8NO. Compound P is a colorless liquid with a fruity smell. So what this gives an idea, this gives you an idea that because of fruity smell, that gives an idea that it should be an ester. Because what is the characteristic of esters? They have a fruity smell. They are also used as artificial flavors, esters, different esters. So when a sample of a pea is heated with sodium hydroxide, a volatile product was formed. Basically, when we heat this, either ester can be hydrolyzed in acidic or alkaline medium. So when ester is hydrolyzed, it will produce alcohol and carboxylic acid. So it form a volatile liquid and which is having a molecular ion peak mass to charge ratio of 746. So what this gives an idea, if it produce because whenever esters are hydrolyzed, either acidic or alkaline condition, what it result in a formation of carboxylic acid plus alcohol. And alcohol is a volatile liquid. Alcohol can easily be converted into vapors. And the mass spectrum of this volatile liquid alcohol is 46, like mass to charge ratio. Then the mass spectrum of a P has a strong peak at 43. So mean majority of them broke down into 43. Deduce the structure. Look, first thing, from this 46, which alcohol could be there? If it is CH3, CH2OH. If I say if it was, because if it was methanol, or here 12 multiplied by 2, 24, carbon is 24, plus hydrogen 3, 4, 5, and 6, so 30, and plus 6. So it means it should be ethanol, because the ethanol peak is 46. So when we have ester, C double bonded with O and O will be there. So the part which is attached with oxygen is coming from alcohol. And which alcohol is there? Because it is it is producing an ethanol, so it should be 2 carbon here. Because molecule break down, it form alcohol. And total number of the carbon are 4. So 2 are already there. So then remaining 2 carbon and 3 hydrogen. So how many? 1, 2, 3, 4, 5, 6, 7, 8 hydrogen, 4 carbon, and 2 oxygen. So C4H8NO. So the idea, the fruity smell is giving an idea that there is a ester present. The mass to charge ratio of 46 present shows that there should be a peak due to presence of ethanol. And the peak which is there 43. So this is 12 multiplied by 2, 24. 24 plus 6, this will be 40, and plus 3. So this peak is our 43. So you will draw the structure and you can represent according to the question. Next is question number 3. The doubts 3B, D, E, F. Okay. 3B. Okay, what is happening in this? I will read because the question is totally related. So I will discuss all of it. A group of students carry out an experiment to determine the rate of equation between the reaction between bromide and bromate 5 in acidic condition. So the equation is given. So this equation is shown here. Procedure 1 to determine the order of the reaction with respect to bromate 5 ion. We took 10 cm cube of phenol, aqueous phenol in a boiling tube, and then we add 5 drops of methyl red indicator. The mixture turned yellow, the alkaline color of a methyl red, and then 5 cm cube of so then 5 cm cube of aqueous potassium bromide and 10 cm cube of sulfuric acid was added in a boiling tube, and the mixture turned red. The acid color of methyl orange is red. Then measure 15 cm cube of potassium bromate 5 in a second boiling tube and mix the content in 2 boiling tube and start the timer. Then record the T when the color of a methyl red is bleached from red to colorless in excess of bromine. So basically what happened, why we are using a phenol here, see, when bromate 5 ion is reacting with bromide ion, it is producing bromine. And in a test tube, phenol is not the main reactant. In a test tube, why, how we are identifying this? Because bromine, what is the tendency of a bromine? Bromine has a tendency to bleach the indicator. Like group 7 or halogens, they have a characteristic to remove the color from the indicator. So they have the characteristic to bleach the indicators. So how we determine the rate of reaction, like how much time the indicator take to turn colorless or bleach completely. If it bleaches in a short time, then we will say that the reaction is fast. If they take longer time to bleach, it means the reaction is slower. So this bromine is used as an indicator here. But why we are using a phenol? Why not directly? Why not without phenol? Because what will happen when they bromate 5 ion and bromide ion react with each other, it forms bromine molecule. This bromine molecule, if there was no phenol, like in the question, if there was no phenol and we were using a methyl orange or a methyl red as an indicator, so instantly this methyl red will be bleached. So if instantly methyl red will be bleached, it will be difficult to identify how much time it took for a reaction to complete, because when bromate 5 ion reacted with bromide ion, they react with each other, from bromine, and instantly bromine which is produced will bleach the methyl red. So it will be very difficult to time this reaction. So what we do, we add phenol here, because phenol can be oxidized easily, or bromine can be added to phenol. So this bromine added to phenol. So once the all of the phenol reacted with bromine, now there will be no more phenol to further react. So means the indicator will take some time to bleach, or indicator will take time to turn into colorless, not instantly. So once bromine produced reacted with phenol, once all of the phenol is reacted with bromine, now extra bromine which is produced, that will bleach. So we will have a sufficient time to identify that whether a reaction is fast or slow. Otherwise, if there was no phenol, instantly bromine produced and it bleaches the indicator. Then we record the time for a methyl red is bleached from a red to colorless in excess of bromine. Then two hazards are mentioned, is important hazard associated with the phenol in this experiment. So as you can see, one is a poisoner, another one is a corrosive. So if something is poisonous, like it is poisonous, or corrosive can be, phenol is corrosive, so we should wear gloves. The most appropriate hazard associated with the phenol in the experiment and precaution we should take to reduce the risk, apart from wearing safety goggles and lab coat. So then state the purpose of the phenol. What was the purpose of the phenol? So to react with bromine and it will take some time to bleach the bromine will take some time to bleach the indicator, so we can easily identify the time interval. Suggests a way of making a disappearance of a methyl red easy to see. So we should always, like if we want to see, observe a color change, so we should always use a white background. Then these are the reactions we are using: bromatine, bromidine, sulfuric acid, water. So why the total volume is same, constant for all? When we are using a total volume constant, so that the concentration is directly proportional to moles. Like the one which will have, volume will be directly proportional to the concentration. The one which will have large volume in the mixture, it means that is having a high concentration. So here 15 plus 5, 20, 20 plus 10, 30. So total volume is 30. Here also 12, 5, 10 and 3, so 30. So all have the concentration is inversely proportional to volume, but see, the idea is that, like, if I have, so that the concentration proportional to volume for each solution. Like example, the total volume here is 30, total volume here is 30. All have the total volume 30. But when I compare the proportion, like this solution and this solution, we mix like 15 cm cube of bromatine, the first one, and the second one, the last one, we use 4 cm cube of bromatine in the mixture. So compared to 30, compared to total volume 30, 15 is bromatine volume, and compared to 30, 4 cm cube is bromatine. So which solution contain a higher concentration of a bromatine? So the one in which that is having a greater proportion of volume. So it means this will have a high concentration and this will have a low concentration. So that concentration proportional to volume, what does it mean? It means the solution which is having more volume of that specific substance will have a high concentration of that substance. Not for one solution. It's like comparison, the solution experiment in which we have more volume of that substance, it means that will have more particles in it compared to a solution which is having a smaller volume. Then we will plot a graph, state the order of a reaction with respect. So you have to check, because from the graph you can only predict whether it is a first order, second order, or third order. So if it is a straight line, then it will be first order. Horizontal line, it will be zero order. The reciprocal 1 over t is measured, measure of a rate of this experiment. Suggest an assumption on which this depends. Refer your answer to shape of the graph of a reactant concentration against the time. So basically, when we work out the order of the reaction, this will be first order. It should be a straight line, so it will be first order. So what we did, the reciprocal time 1 over t is used as a measurement of a rate in this experiment. Suggest the assumption on which this depends. So on which assumption, what we assume for this? So we consider the initial concentration, like the concentration is changing with the same rate, or the mixture is uniformly mixed, like the particles are uniformly mixed in the solution. So the assumption for this experiment is basically we assume the concentration, initial concentration or initial concentration is constant. In the beginning, like the moment we mix, that moment the reaction we assume that does not happen or its concentration is constant. And refer in your answer shape of typical graph for concentration for graph for reactant concentration against time. So if you have a reactant concentration and time, if it is a first order reaction, then it will have a constant half-life. So this will be the shape of the graph. It will be constant half-life, like every time it will take this means equal time interval will be there for a reactant to convert into product or half of the product. Another student accidentally measured 8.5 cm cube of potassium bromate rather than 8. Explain whether or not this proportion of potassium bromate should be discarded. So what we have to do, like student, instead of adding 8.5 measured 8.5 cm cube rather than 8. So what he should do, like example, because he's mixing, he's adding a water to make the total volume same. So if he's adding, like example, instead of 8, if he had 8.5, so only thing what he have to do, because the water is used to make the solution, overall solution having a same volume. So what he can do, he can reduce the amount of the water added so that the total volume will remain same. So he should not discard, just make a total volume same by adding a like small proportion like 6.5 cm cube of water. Then in part E, all the volumes measured in this experiment were made using 50 cm cube burette. Give a reason why potassium bromate solution first made it into separate boiling tube rather than directly into a mixture. Like why we don't mix them together, why we in a separate, like potassium bromate 5 is there and bromide ion is there. We don't mix them initially, like we do not directly mix them together. We take a separate boiling tube and then we mix them together. So what is the reason for that? Like why not directly we add from the burette, like we took 50 cm cube of potassium bromate here, but we did not transfer into a reaction mixture. We first transfer into a separating test tube and then mix. So what is the reason for that? Because burette is an accurate measurement. Using a burette, we can measure it accurately, but the problem is it will take time to transfer. So maybe if directly we try to mix the two substances with each other, but because the burette will take time to transfer, so the reaction won't be accurate. Is it clear? Part E1. The simple idea is that because burette take time to transfer. Like if I try, like I fill a mixture, like I have potassium bromate, I have 50 cm cube of potassium bromate. For a reaction, I need 50 cm cube, and I want to mix with bromide ion. But I did not directly add. I want to react all 50 cm cube. If I want to react all 50 cm cube at once, so I cannot use a burette because burette take time to transfer. Gradually, the liquid will transfer into the conical flask. So better first we take in a boiling tube and then from a boiling tube instantly we transfer into another test tube. Next part, give two reasons why run 1 has the lowest uncertainty in the volume measurement. Look, uncertainty, what it depends on, percentage uncertainty or uncertainty, that is uncertainty divided by value recorded into 100. So if we record a larger volume, larger value, it means percentage uncertainty will be lower. So because we are recording the first experiment, we recorded 15 cm cube. The last experiment we recorded only 4 cm cube. So which one is the most accurate? Like which one have a lower percentage uncertainty? So here percentage uncertainty will be lower, and here percentage uncertainty will be higher. That's why like experiment which involve measuring a time period of a simple pendulum, so we prefer to record for like 20 vibration or 30 vibration. Why not one? Because if we record for one vibration, it will take like longer, like increases the percentage uncertainty, because the value recorded will be smaller, so uncertainty will be higher. Then state the change that you would make to procedure to obtain data needed to determine overall rate of reaction between bromide and bromate in acidic condition. So because if you want to determine the overall rate, in this experiment we just work out for bromate 5 ion BrO3 with a charge -1. So what we should do, we should repeat the experiment with different concentration or different volume of a bromide ion, and then for acid. But we should keep the total volume same. Here, like this part, in this experiment, what we did, this whole data is used to identify the effect of like this order of a reaction with respect to bromate, because that is only which we changed. The rest other remain constant, and water is just to make the overall volume same for all each experiment, so that the one which will have more volume in this mixture, that will have a high concentration. Now, if you want to determine overall rate, so we should know the rate with respect to bromate. So bromide ion. So what we'll do, we'll change the concentration of bromide and we'll keep bromate and sulfuric acid concentration constant, but keep the total volume same for each experiment. Then we'll repeat the experiment with different volume of sulfuric acid, but keeping bromate and bromide ion concentration or volume same, and the total volume should also be constant. So just you have to mention, like repeat the experiment by changing the concentration of bromide and sulfuric acid, but keeping the total volume same for each experiment.